So in this video, we're going to take a look at some common careless mistakes students make when answering Redox questions. Hi everyone, it's Jeremy from the classroom, and let's get started. So here you're given a question, and the first part basically says this: complete a table to calculate or to show the oxidation states of sulfur and chlorine in your reactant and product. So let's look at the reactant first. Sulfur is here, it's S2O3, it's 2 minus, alright, so it's an ion, it's an anion. Now recall, when you want to calculate oxidation states, step 1, you want to split the substance into elements. Okay, so if there are 2 elements, we split into 2. Now then always fill in oxygen, hydrogen, group 1, group 2 first. Once again, oxygen, hydrogen, group 1, group 2. If there are these substances in the reactant, fill it in first. Here there is oxygen, so we're going to fill that in. -2 and 3 gives us -6. Then you want to ask yourself this: what must sulfur be so that the overall charge is -2? Okay, so it's a bit of basic math, right? What minus 6 is equal to -2? And this is +4. So the first common careless mistake some students will make is they will write a +4 there. But that's not correct. Okay, so if you write, oh, +4, bang, wrong. How come? Alright, now you got to understand that there are 2 sulfur atoms here, it's S2. So the oxidation state of each sulfur is actually only +2. You've got to take +4, divide by 2, you get +2. And so it's +2. Okay, so that's first part. Now what about oxidation state of sulfur in the product? So in the product we have, let me just erase that, yeah? Okay. In the product we have 2SO4 2 minus. Okay. So what some students will do wrongly is they will put the 2 inside. Oh, teacher, I've got 2 here, right? And O4, right? So oxygen is -2 times 4 times 2 is times 8 minus 16. And that's not correct. So you need to understand this. When you're calculating oxidation states, do not include the number in front. The number in front here, there's 2 here, alright, the 4 here, and the 5 here, they're all used to balance chemical equations. They're not used to calculate oxidation states. So don't include that. If you want, you can cancel it with a pencil. Don't use pen. O level, you cancel with pen. You cannot see the number, you're going to be in trouble. Okay? Alright, so I'm just going to talk about SO4 2 minus. Same thing, split it into elements, fill in oxygen first. -2 and 4 gives us -8. So you want to ask yourself the same question: what must sulfur be so that the overall oxidation state is now -2? And this is +6. So +6. That will give you 1 mark. Okay, so you have 4 blanks to fill in, 2 blanks will give you 1 mark. Okay, now chlorine. Okay, so here you're given a substance. I'm going to circle in black, chlorine. It is uncombined. It has not undergone a reaction yet. So elements that are uncombined by themselves have not yet lost or gained electrons. There is no charge. So 0. Okay? In the product, it is 8Cl minus. Once again, we don't look at the 8. It is just Cl minus, right? So if the charge is -1 minus, oxidation state is -1. And this will give you your 2 marks. Alright, now moving on, the question basically says this: identify the reducing agent. So one common mistake I've seen many times students make here is this. They'll say that, I study in school, right? The reducing agent is a substance that is oxidized. The one where the oxidation state increase. So the sulfur, here, oxidation state from +2 become +6, right? From +2 become +6. Sorry about the car in the background. Alright, so from +2 to +6, what happens here is this: it is oxidized. So I know the substance that is oxidized is the reducing agent. So I write, S2O3 2 minus, alright, is the reducing agent. And then they ask you to explain, you write, it is oxidized. Then this is, you get a big fat cross, it is not correct. Okay? Now you've got to explain that something is a reducing agent because of what it does. It's a reducing agent because it reduces the other guy. Alright, so in this case, the correct answer is, it reduces chlorine to Cl minus. And how do we know this? The oxidation state of chlorine decreases from 0 in Cl to -1 in Cl minus. Okay? If sometimes the question goes a little bit more and say in terms of electrons as well, you can say that it's a reducing agent because why? It is an electron donor. Alright, it basically gives away electrons, and therefore it's a reducing agent. So here, there were actually 3 careless mistakes I highlighted. I hope you caught that. Number 1, alright, make sure if there is a 2 there, you divide the oxidation state by 2. or by 3, or by 4. Number 2, we do not look at the number in front, okay, so we cancel that out. And number 3, when you want to explain why something is a reducing or oxidizing agent, tell me because of what it does. Alright, here, it is a reducing agent because it reduces your chlorine to your chloride ions. So I hope you learned something useful, and I'll see you next time.